Algebra 2 Note 7.5 Exponential and Logarithmic Equations. So these are the ones we have been doing if you can write your exponential equations with a common base. So we see a 16 and 8, so we're thinking, can we write both these as 2 to some power, or 3 to some power, or 4 to some power? What can we rewrite them as? They can both be written as 2 to some power. So think about 2 times itself. How many times gives us each of these numbers? So 2 times 2, that'd be 4. Another 2 would be 8. 4 of them to get us to 16. Okay, and then 2 to the third to get us to 8. Don't forget about this 3x here. So then remember, we're going to multiply those exponents. So we have 2 to the 12x equals 2 to the third. And finally, once you have the bases to be the same, the common base, we can then set those exponents equal to each other. So we can divide by the 12, and then simplify what goes into both 3 and 12. So we can divide by 3. X equals 1/4. Okay? All right, why don't you pause the video and try the next two? All right, 27 and 81, we can write both those as 3 to some power, 256 and 64, 4 to some power, and then just continue solving. What if our bases can't be written as the same? So if you have different bases, what you're going to do is take the logarithm of both sides. So if we want to take the logarithm of both sides, we'll take the logarithm of 15 to the 3x and the logarithm of 285. The reason, again, we can't rewrite these both as 15 to some power because 285 is not 15 squared or 15 to the third. All right, now we've got to go back and remember our power property with the exponents. So this 3x we can bring out front. So it's going to be 3x times the logarithm of 15 equals the logarithm of 285. Now, since these are base 10, because there is no base there on these logarithms, we could type this in our calculator, but you're going to get the more accurate answer if you wait till the last step to type it in on your calculator. So since these are all being multiplied, if I want to get x by itself, I can divide by that 3 and the logarithm of 15. So we're going to divide by the 3 times the logarithm of 15. So over on the left side, the 3's will cancel, and the logarithms of 15 will cancel, so you're just left with x. On the right side, we're just going to calculate that. Now we've got to be careful when we calculate this, because when I do my denominator, I need to make all of that be division, so that means I need a parentheses around my denominator. Okay, so if we do that on our calculator, if you're using the geometry calculator that you used last year, you can type it in just like it looks with that parenthesis. If you are using kind of your computer calculator, you might have to type it in a little bit different. So I have to actually type in 285 log, but now if you look up here, you can see that it's the logarithm of 285 divided by, start your parentheses, 3 times the log of 15. Equals. Okay, and then go ahead and round it to the thousandth place, so 3 decimal spots. So let's talk about that real quick. 3 decimal spots, 0.6957. That 7, does that make the 5 stay 5? Or does the 7 bump the 5 up to a 6? Look at that one more time. So our original decimal was 0.6957. That 7's going to bump the 5 up to be a 6. So your final answer would be 0.696. 696 thousandths. All right, let's try this next one. Why don't you guys try the last two here? So take the logarithm of both sides. You're going to have to pull that exponent out front and then divide. All right, the second one there should be 1.512, and that last answer should be 0.870. Now, if you want to check your answers on these, you could always put that number back in and make sure it gives you that right answer. So we could go 6 to the 4 times 0.870 and see if it gives you about 512. Now, since we rounded it, it's going to be off a little bit, but it should be pretty close. Solving logarithmic equations. So remember, we can put them back into exponential form, okay? Use exponents to solve the equation. So just keep in mind, logarithm base b of x equals y can be written as b to the y equals x, okay? Now remember, if there's no base, it's a 10. So we can rewrite this one, 10 to the second equals 4x minus 3. And solve. So add your 3, divide by 4. Okay, so these ones you can also have a 10 there. So why don't you pause your video, see if you can solve the last two. All right, go ahead and check those last two. Make sure you got those to come out. And we'll head to our last section. Okay, this time we've got to use kind of what we did just now, but also the logarithm properties. So if I take a look at this, I first have these two logarithms that are being added, but they both have the same base. If there's no base, it's a 10. So I can rewrite these as one single logarithm. And then I'm not going to keep it as an addition problem. I can change it to a multiplication problem. So x minus 3 times x. So if I want to rewrite that and simplify that there, so log base 10 of x squared minus 3x, if I distribute my x, equals 1. So then I can put this back into exponential form. 10 to the first equals x squared minus 3x. We can subtract the 10. And factor. So what multiplies to be 10 that has a difference of 3? We can say 5 and 2. 5 should be in the negative. All right, so then set those both equal to 0. So x equals 5 or x equals negative 2. Now when I plug that negative 2 back in, that's going to give me the logarithm of a negative number, which we cannot do. So you could have extraneous solutions. So check your answers to make sure they work. Okay, if I put 5 in there, 5 minus 3 is 2. So log base 10 of 2. If I put 5 in the next one, log base 10 of 5. And then you could keep going and solve it if you want, or check it if you want. All right, why don't you guys try the second one? So pause your video and we'll do the third one together. All right, go ahead and check your answer for this next one. And we'll head to the last one. Logarithm 2x squared minus logarithm 5 equals 1. So again, they have the same base. So right away, let's go ahead and put these two together since it's a subtraction. We can rewrite it as logarithm of 2x squared over 5 equals 1. So then go ahead and put it back into exponential form since our base is there. 10 to the first equals 2x squared over 5. So we could think of this as like 10 over 1. And then 5 times 10, cross multiply. I do those two. And then I could multiply these two. And then we get 50 equals 2x squared. We can divide by 2. And finally take the square root. Don't forget, when you take the square root, you need plus or minus. Now we need to see, do both plus and minus work? Well, if I plug -5 back in, I am actually going to square that -5 before I do anything. So yes, that -5 is going to be okay to plug in. All right, so x is going to be both of those. Okay, so you can get started on the assignment, the textbook assignment, and it's also posted online.